Okay, this is chapter 7. We're starting our applications chapter involving right triangles. And these are the problems that you have to turn in for your flip. So those are the ones we'll go over. Okay, the first one is number 9. And they gave you the triangle. The right triangle looks something like this. And you have 12 and 5. So you should know the hypotenuse is 13. And you just fill in SOHCAHTOA. So, and they're looking for the values given this angle here. So sine is opposite over hypotenuse, which equals opposite is 5, hypotenuse is 13. Cosine is adjacent over hypotenuse, which would equal 12 over 13. And tan is just opposite over adjacent, which is just 5 over 12. And we've been doing this so much that I think this is going to be easy for you. So cosecant, you just flip it opposite over hypotenuse, which equals 13 over 5. Secant is hypotenuse over adjacent, which is 13 over 12. And cotan is adjacent over hypotenuse, which is 12 over 5. Okay, the next one you have to do is 19. This involves complementary angles. So on 19, you need to look in the book about the complementary angles. And they're fairly simple. The main thing you need to know is that they have the same value every 90 degrees, especially with sine and cosine. So for sine of 38 minus cosine of 52 degrees, we can write this as sine of 38 degrees minus sine of 90 minus 52. So we will get sine of 38 degrees minus sine of 38 degrees, which equals 0. Or you could have done it this way. You could have said cosine of 90 minus 38 minus cosine of 52, and all these are degrees, is cosine of 52 degrees minus cosine of 52 degrees. Alright, and this part, let me find it in the book. This is, part is on page, 520. So it's called the complementary angle fit theorem, and you need to know it. So, complementary angle theorem. Okay, next problem we're doing is 29. So 29, they give you a triangle. It looks like this. And they have C, B, and A. So this is A, B, and C. And always remember the side across from, the angle across from B is always beta, and the angle across from A is always alpha. And they want you to find all the values for this. So the way we're going to do it, you can do it in different ways, but since we know that beta equals 5, or B equals 5, and beta equals 20 degrees, I'm going to use tan of beta equals B over A. So tan of 20, you need a calculator for this, equals 5 over A. I'm going to cross multiply, so we have A equals 5, that's A, over tan of 20. Use your calculator. Erase this a little. 20 degrees, which equals 5 over 0.3640, which equals 13.74. Now, to find, let's go to the next page. To find beta, we'll use sine of beta equals B over C. So sine of 20 degrees equals 5 over C. So C equals 5 over, you cross multiply, sine of 20 degrees. And you can put the whole thing in the calculator and get 14.62. And then to find alpha, since you know there's 120 degrees or 180 degrees in a triangle, you could just take your 90 minus beta, which equals 90 degrees minus 20 degrees, which equals 70 degrees. Okay, so you found all your sides. Okay, the next problem we have to do is 39. So 39 is A equals 5, B equals 3, and so we need to find C. And we know that we need to find C. So C squared equals A squared plus B squared, which equals 25 plus 9, which equals 34. Now, what's nice about this chapter is you do get to use a calculator. So C equals the square root of 34, which equals 5.83. Then to find alpha, we're going to do tan of alpha equals A over B, which equals 5 over 3. And then we're going to take the inverse. We can take the inverse of both sides. And then we're going to go ahead and take the inverse of this too. We get alpha equals tan inverse of 5 over 3, which equals 14 degrees. And then to find beta, we're just going to take beta equals 90 degrees minus alpha equals 90 degrees minus 14 degrees, which equals 76 degrees. Okay, the next problem is looking for the pencils, 49, and we're going to go ahead and draw a picture of 49. We can draw something like this. I'm going to go ahead and draw this like this. Go back and draw this and this. You can draw your triangle any way you want. I'm going to do it this way. This is C, B, and A. I always make my C my right triangle. My right angle, I mean. And this is 35 degrees here. So for 49, all you're going to do is use tan of 35 degrees. Did I write this as 30? That's 35. So tan of 35 degrees equals, the length of this, I forgot, is 100 feet. And we're looking for AC, because it says find the distance from A to C. So we're looking for this angle. So I'm just going to write this as AC, the length of AC over 100 feet. And then I'm going to just cross up. So this is put in fraction form. So 100 times tan of 35 degrees equals the length between A and C. And that's going to be, if you use your handy dandy calculator, 83.91 feet. Okay? The next one's 52. 52 is the Eiffel Tower picture. I'm not going to draw the Eiffel Tower, but I'm going to draw the triangle. So we have this, this, and then I'm going to draw the dotted line like they do. Alright? This angle here, they say is, and the way they do it, I'm going to do the same things for a room, 85.361 degrees. And the length between here and here is 80 degrees. Or 80 feet, sorry. So for 52, we're going to let x equal this, not 52, we're going to use tan of 85.361 degrees equals x over 80, cross multiply, so you get x equals 80 times tan of 85.361 degrees, which equals 985.91 feet. Okay. The next one is, and while y'all are watching this, the ones that are, you need to know how to do 52. 52 is on your unit test. I'll probably do a separate video on that one. Alright, the next one is 59, about Mount Rushmore. So you need to read that. And I will try to draw a picture. Always draw a picture. So the picture I'm going to draw, and I'm going to let H represent the height of Lincoln's face. So I'm going to draw it this way. So this is B. The length here is 800 feet. This angle here is 32 degrees. And then this is your height here. Then the whole angle here is 35 degrees. Again, please read the problem. So it's 35 degrees there. So the first thing I'm going to do is let tan of 32 degrees equal B over 800, cross multiply, so B equals 800 times tan of 32, which equals 499.9. Now, the next part is the hard part. So, tan of 35 equals B plus H. Before it was just what? B. But we have this additional H here. So B plus H over 800 feet. And so then I'm going to cross multiply and say B plus H equals 800 tan of 35, or 32, or 35, right? 35, which equals 560.17. Now, to get the real height, we're going to subtract, because this is the B plus H here, which is what we have here, and then we have B, which we have here. So to find that, I'm just going to take 560.17 minus 499.90, and I get 60.27 feet. Okay? And do we have any more? I think that's it. Let me see. Any pencils? Oh, one more. 67. So the last one is 67. And let's look at 67. 67 is finding the bearing of an aircraft. So I'm going to draw this for you. We're going to draw it this way on a coordinate grid. And I'm going to call this D. And I'm going to call this A. And this point C. And I'm going to draw it this way. So A, B, go down. It goes down below. I'm going to draw this out a little. So it's C. You have to read the problem, please, and back up. So there's my triangle. They're saying from A to B, it's half a mile. It's 0.5 miles. And they're saying that this part right in here is 40 degrees. And the length between B and C is 1 mile. Okay, and we're going to try to find the angles. This is your right angle right in here. So, first thing we're going to notice is this is our theta. So tan of theta equals 1 over 1/2, which equals 2. If you take the inverse, you get theta equals 63.4 degrees. Now they want the measure of A. Okay, so they want this, and the measure of A, or DAC, equals 40 degrees plus 63.4, which equals 103.4. We're going to do the same thing for EAC, and E is right here. So this is EAC. So this right in here. This is what they're talking about. Right in there. So angle, that is going to be 103.4 minus 90, which equals 76. Well, 103 minus 90 equals 13.4. Now, what they really want is the bearing. So what we're going to do is we're going to take 90 degrees minus your 13.4 from here, and that gives you, that equals 76.6 degrees. So the control panel or control tower should be a bearing of 76.6 degrees east. This was a hard one. This one was what, 67? Don't worry, you won't have like one of these on your unit exam, but I wanted to do it for your flipped part. And that is it for the flipped. Be looking for 52. 52 is the one you need to know for your unit exam.